So the last model that we're going to talk about in this section is the Stackelberg leader-follower model. This really builds on Cournot to think about what if we have a more sequential game. So a sequential game is where one person moves first and then someone else moves second. Up until this point, we've been assuming that everyone makes their decisions simultaneously, but a big portion of game theory and obviously situations in the world have this type of sequential timeline. So here we're going to assume that firm one is the Stackelberg leader. Firm one moves first, and then firm two reacts. And we're going to use the same demand function and marginal cost as in the previous example. So really we can carry our reaction functions over from the last video. So I'll just remind you that we solved for both firm one and firm two's reaction functions, and they were 45 minus 1/2 Q2, and then the reaction function for firm two was the same. This is Q2 and this is Q1. Okay, so we starting with these reaction functions. Now we want to think about how the incentives change if we have a sequential framework. So firm one will move first. They will choose the quantity they produce, understanding that firm two will observe that quantity and then react. Okay, so no more simultaneous moving. Firm two sees firm one's quantity, plugs it into their reaction function, and then reacts. But firm one knows that. So firm one is going to make their best choice by taking into account firm two's anticipated reaction. So let me just write that down because it's like a little bit inception here. Okay, so in order to make the best choice, firm one, the leader, will take into account how the follower, firm two, will react. Okay, so what we're going to do is we're going to think about firm one's problem taking into account firm two's reaction function. So if you recall, when we write out residual demand for firm one, we've got P equals 100 minus Q1 minus Q2. And before we just held Q2 constant, we didn't know what it was. And so we left it alone. But now we do have some more information about Q2. We know that Q2 will be determined by firm two's reaction function. So we're going to take firm two's reaction function and we're going to plug that in for Q2 so that firm one's choice reflects how they anticipate firm two to react. Okay, so that's 100 minus Q1 minus 45 minus 1/2 Q1. And so I'm going to just simplify this. So I've got 100 minus 45 is 55. And then minus Q1 plus 1/2 Q1 is like minus 1/2 Q1. Okay, so now this is my new residual demand equation for firm one. And based on that, I will have make my profit maximization decision. Okay, so this is firm one's residual demand. Okay, so firm one has this residual demand equation. They're going to right? Find total revenue is going to be 55 Q1 minus 1/2 Q1 squared, and then marginal revenue will be 55 minus Q1. Set that equal to marginal cost, and then solve Q1 will equal 45. Q2 will observe that and then react. So Q2 will produce 22.5. Our total quantity here is the sum. So that's 67.5. And then we can plug that back into demand to get the price. So we've got a price of 32.5. All right. So the last thing that we want to do is compare all of these different models and their predictions about how firms in an oligopoly market will behave. All right. So we've already plotted on the last page the monopoly outcome and Cournot, but I'll remind you that Monopoly produced 45 units, charged a price of 55, and this is Monopoly. They earned a profit of 2,025. Then down here we have Bertrand, profit equals 0. Cournot was 60. And 40, and each firm earned 1,800. And then in this model, the firms are going to earn different amounts of profit because they're producing different quantities. So the Stackelberg leader, that's firm 1, is going to earn profit equal to 1,012.50. So that's more than the firm earned in the Cournot equilibrium, right? The leader takes advantage of this situation and strategically increases their output to earn more profit in the Stackelberg model. So this is more than Cournot. But the follower will earn less. So we've got here 22.5 times 32.5 minus 10 quantity. And then we've got a profit for the follower of 506.25. So that's less than in Cournot, and the total profit in the market is going to be less. You can see they've produced a larger total quantity than in Cournot. They just produced 60. So again, we're moving away from the monopoly outcome. And so profit is going to be decreasing. Stackelberg. And our total profit here is 15, 18, 75. So although the leader makes more profit in the Stackelberg model and the follower will make less profit, the total market profit is lower than in the Cournot model. So I think you can see some sort of similar trends throughout all of these models, which is that although firms do best by agreeing to collude and set the monopoly price, really, each firm always has this incentive to try to game the system, to undercut their competitor, to lower their price or produce a little bit more, increasing their own profits in the short term, but decreasing the market profits. And this incentive for competition, although bad for the firms, is good for consumers and leads us to an outcome that has higher consumer surplus and higher total surplus.